Exercise shear force diagram and bending moment diagram by using four concepts. That is, the slope in V diagram is equal to minus W, and the slope in moment diagram is equal to V, and when there is a point force in upward, the shear force diagram will increase at that point, and if there is a couple M0 applied in clockwise, the bending moment diagram will increase. So use this to draw the diagram by using the graphical method. Start from point A. So from the point force 7.5 kilonewton. So when there is point force in upward, the shear force diagram we start from 0. So the shear force diagram increase by 7.5. So there is 7.5 here. And due to W is 0 in section 1, in this section, so the slope in this section is always 0. So this line shows slope 0. And then due to 10 kilonewton, so shear force diagram will decrease by 10. So n value is 2.5. And due to W 0, you can draw this line. And from the point force 10, so it decreased more by 10. So this value change to minus 12.5. And due to W0, so you can draw this line, and you can see that at B that is 12.5, so the graph will return to 0. And next, the moment diagram, consider the shear force diagrams and the point couple apply on the beam. We start from 0 and from the section 1, the shear force always constant positive, so the slope always constant positive. So we draw the line that show constant slope, and slope is positive. The value here can be found from the integration equation, that is delta v delta m is integrate v dx, or delta m can be calculated from the area under graph shear force diagram. So this show the change in m value delta m1 from A to 2 meters. So this show this delta m1. So delta m1 from the graph that is 7.5 multiplied by 2, so 15 kilonewton meters. So this value is changed from 0 to 15. And then consider the V value. The V in section 2 is negative constant, and the change in value can be found from this area, and this area delta m2 is minus 5 kilonewton meters. So the value decreased by 5. And the line is a linear line with less slope than section 1, and the value decreased by 5. So this n value is 10. That 5 is the change in value. So this is delta m2. Next, the graph in last section, the v value is negative constant. So the slope is negative constant, and the slope is larger than the slope in section 2. So this shows the negative slope. And the change in m values can be found from this area. So this delta m3 can be found to be 25 kilonewton meters. So the value is dropped by 25. It's dropped from 10, or delta n3 is this value. And so n values here is 10 minus 25, so it's minus 15. And due to apply couple 15 kilonewton meters at point B, so the graph will increase clockwise, so graph increase to 0. So this is the graph from graphical method. More one problems. From the equilibrium, you can find the support reaction to be 32 and 16. And we use same concept. Firstly, let's start from 0. And by considering the bill, so we can see that the bill in section 1 is constant and positive. So the slope in V diagram is constant negative. So this graph show the values, show the shape of the shear force diagram in section 1. The slope is constant negative. And the value here can be found from the relation delta V can be found from the area under W. So we can find n value from this area. And this area shows delta V1, and that is equal to 12 minus 12 kilonewton. So this n value is minus 12 because delta V1 is a change in V value from this point to 1 meters. And then due to 32 kilonewton, the graph increased by 32, so n value is 20, changed by 32. And next, in section 2, the bill is constant positive, so the graph has same slope as first part as this part. So you should draw the graph with same slope. Yes, and this value can be found from the area under graph, this area. This is delta V2 is 36 kilonewton. It's negative. So the value changed by 36 or change from here to here by delta V2. So the n value can be found to be minus 16. And from 16 at the right end, so it returns to 0. To draw the moment diagram, you can see that the shear force diagram in section 2 is divided into two parts, the positive zone and negative zone. So we have to find the value that the shear force cut the x-axis. And so we assume the distance, this distance to be x1. And by using the relation delta V is the area under the bill. So if we draw this, and if we consider this area, so you can see that the change in V value can be found to be minus 20 kilonewton. And it can be related to the area under the bill that can be calculated from minus 12 kilonewton per meter and multiplied by x1. And so we can find x1 to be 5/3 meters. So this x1 is 5/3 meters, and this location is 8/3. So you can find this. We have to find this, and we use this line to draw the moment diagram, and this location 8/3. Draw the diagram. We start from 0. And so from the shear force diagram in section 1, the shear force start from 0, and then the shear force become negative, increase in negative values. So the graph, we draw the graph, have the slope start from 0, and then slope increase, and slope always negative, and the slope increase, and the incline increase, the incline direction increase. And so you draw the graph start from 0 slope and slope increase. And so this curve can show that meaning that you read from the shear force. And this value can be found from the change in M value. And the change in M value from between these 2 points can be related to this area. And so this is delta M1. We can find delta M1 to be -6 kilonewton meters. And so this value is -6. And then the V diagram is changed to positive value, and the value decrease until 0. And so we draw the curve that show start from positive slope and slope decrease to 0. And so it's this slope to 0. This point and this value can be found from the change in M value. So this is a change in M value, delta M2 from 1 to 8/3 can be related to this area. This area delta M2, this area can be found to be 15/3 kilonewton meters. So the value changed by 15/3. So the n value can be calculated to be 32.3 from -6 plus 50/3. And next, we draw the in last section. So the graph start from 0 slope, and then slope always negative, and the slope increase. So start from 0, slope increase, and we draw this curve. And this value should be equal to, it should return to 0. So this delta M3 should be equal to this area. And you can see that this area delta M3 can be found to be -32.3 kilonewton meters. So it's returned to 0.